Hello everyone. For this tutorial video I'd like to talk about gravitational potential energy, as well as give/explain the formula for it. As we should already be well aware, gravity causes objects to move straight down. So if there is a force counteracting it back up, such as a table or a pair of hands, then it must logically be supplying energy to the object to keep it supported. And in particular, if we remember, the exact formula for weight is mass times acceleration due to gravity, then this means it must be the force and the work formula. And fortunately for us, the displacement is pretty easy to find here, as the displacement is simply straight up. So we can rewrite the displacement as h for height. So we conclude that the work done against gravity is exactly mass times acceleration due to gravity times height, and that this must be the gravitational potential energy of whatever object we are lifting. What is interesting about gravitational potential energy, though, is that it can be used to evaluate more complicated paths than simply straight down to up. Just like kinetic energy can be used to evaluate more complicated paths. Because exactly like with kinetic energy, potential energy does not care about the path, it only cares about what is happening at a specific point. So now we can lastly state in a formula that if the only force acting on an object is gravity, then it should follow that when you let a weight go, the change in kinetic energy is exactly equal to the negative change in potential energy. The negative sign being important because it is losing potential, getting closer to the core or wherever you are measuring the gravity relative to. Or with some rewriting, we can state that change in potential energy plus change in kinetic energy equals 0. And this is called the law of conservation of energy. But this only works if the energy is entirely mechanical and does not involve things such as heat or sound. And more often than not, in real-life scenarios, there are heat and sound forces involved, such as what friction causes. But this conservation of energy can still be a good approximation for many situations. In the next tutorial video, we will go into more detail about what I just mentioned, and discuss what conservative force versus non-conservative force means, and how friction is in the latter category. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.